Welcome to The Explainer. Today we're going to talk about something really powerful, a way of thinking that's all about updating our beliefs when we see new evidence. Think of it as a formal way of learning from experience.
So let's just start with a really basic question. When you learn something new, how do you actually change your mind? I mean, in a logical, structured way. How do you go from just a gut feeling to a more solid conclusion? Well, that is exactly what Bayesian thinking is all about.
All right, here's the game plan for today. We're going to start with the big idea, this whole new way of thinking. Then we'll get our hands dirty with a simple example to see how the logic really works. After that, we'll see how it stacks up against the kind of stats most of us learned in school. And finally, we'll see it in action on Wall Street.
Okay, let's jump right in. The thing about Bayesian statistics is, at its core, it's not some crazy, super complex idea that only geniuses can get.
It's really just a formal way of doing something we all do intuitively every single day, changing our minds when we get new information. It's like a mathematical recipe for learning from experience, a way to put numbers on how we go from an initial thought to a much more informed one after we've seen some proof.
But, how does this actually work? An abstract idea is one thing, but let's make it real. We're going to use a super classic example, the coin toss, to make this whole thing crystal clear. Okay, so picture this. You reach into a drawer and pull out a coin, but you have no idea what kind it is. It could be a regular, fair coin, or it could be one of two different bent coins. Now the key is, before you even flip it once, you already know a little something based on what was in that drawer to begin with.
So this initial gut feeling, in Bayesian terms, that's called your prior. It's your starting point. And because we know there are 5 coins in that drawer, we can put some numbers on it. There's a 40% shot it's type A, another 40% it's type B, and just a 20% chance it's that really bent type C.
All right, now it's time to collect some data. Let's flip the coin. Boom, it comes up heads. Now we have a new piece of the puzzle. This is where the likelihood comes in. It basically asks, okay, assuming I had coin A, how likely was it that I'd get a heads? Then it asks the same for B and C. And obviously, getting a heads is way more likely with that super bent type C coin than with the fair one.
And that brings us to the grand finale, the posterior. This is it. This is our new, updated belief. It's the magic that happens when you perfectly blend your starting belief, your prior, with the new evidence you just saw.
And this simple-looking formula pretty much sums up the whole idea. Your new belief, the posterior, is basically your old belief, the prior, times how well the new evidence supports it, which is the likelihood. It's that elegant. So if we look at it visually, this is our starting line. Before we did anything, types A and B were neck and neck. They were the most likely coins we could have grabbed just based on how many of each were in the drawer. And here's the math in action. It's pretty straightforward, really. For each type of coin, you just take your prior belief and multiply it by the likelihood of getting that heads. That gives you this middle number. Then, to make it all make sense, you just adjust those numbers so they add up to 100%. And voila, you've got your new, updated beliefs, the posterior probabilities.
So look what happened. After just one flip that came up heads, our beliefs have totally shifted. Type B is now our front runner. And what's really cool here is that even though getting a heads was most likely with type C, our initial belief that type C was pretty rare held it back. The prior acted like an anchor, so one piece of evidence wasn't enough to make it the most likely.
Now, this whole way of thinking, the idea that you can have a belief about something and then update that belief, that's a really different way of looking at the world compared to the stats class most of us probably took back in the day.
And that brings us to this big split, this kind of philosophical divide in the world of statistics. You have the frequentists who think of probability as something that happens over the long haul. If you flip a coin 1 billion times, what percentage is heads? But then you have the Bayesians, and they see probability as a degree of belief. It's a measure of how certain you are about something, and that certainty can and should change when you learn new stuff.
This little phrase here just nails the difference. Bayesians are all about the data they actually got. They're looking at the evidence right in front of them. Frequentists, they're often thinking about all the other possible data sets they could have gotten if they ran the experiment again and again and again.
Okay, so who cares, right? Coin flips are fun, but why does this matter in the real world? Well, let's take this whole framework and apply it somewhere where the stakes are a lot higher, Wall Street.
In the world of finance, one of the biggest questions is about volatility. How much is the market going to swing around? It's a huge deal. And they use these super sophisticated models to try and figure it out.
But these models are so complex, you can't just do that simple prior times likelihood calculation we did for the coin. No way. You need a much cleverer approach to figure out what your updated belief even looks like.
And that's where this amazing computational trick called MCMC comes into play. Just imagine you're trying to map out a mountain range, but it's totally dark. You can't see it. So what do? You start walking around, and every few steps you record your location. If you do that thousands and thousands of times, eventually all those little dots are going to start to show you the shape of the mountains, where the peaks are, where the valleys are. MCMC does pretty much the exact same thing, but instead of mapping a landscape, it's mapping out the shape of our complex, updated belief by taking thousands of little samples.
Now, when you first kick off one of these simulations, it can be a little wild, kind of like an old car sputtering to life before the engine settles into a smooth hum. That chaotic start is called the burn-in period. So to make sure our final map is accurate, we just throw away those first few thousand messy samples. We only look at the results after the whole thing has stabilized and is running smoothly.
And here we are, the final payoff. After all that fancy simulation and sampling, we get actual usable numbers. And what's really important to see here is that the Bayesian estimates are sitting right there next to the answers you'd get from traditional methods. It just goes to show that this whole process, from our initial beliefs all the way to these complex computer simulations, actually works. It gives us solid, reliable answers.
So think about that. We went from a simple coin flip all the way to the heart of Wall Street, and it was all driven by this one really elegant idea about how to learn. It kind of leaves you with a big question, doesn't it? If we have this powerful, logical way to update our beliefs about something as complex as the financial markets, what else should we be updating our beliefs about?